Yeah, thank you very much and welcome everybody. It's going to be a very interesting session, a lot of code, so be prepared. What I'm going to show you is how to build a GNTKI search right in the database, in Azure SQL specifically. And everything I'm going to show works for Azure SQL. Right now, you can go online and use it, but also it will also work on SQL Server 2025 that has been announced today. So if you want to go and download SQL Server 2025, everything I'm going to show here will also work on premises, so it's pretty cool. So this is the very quick agenda. I only have 15 minutes, 5 minutes for basically theory, and then 10 minutes for coding. So let's move into that. And first of all, why we are doing this? Because data is the fuel that powers AI. And I'm sure you already have plenty of data in your databases. Could be, contracts, could be description of product, could be information that you gather about the customers. And you want to use AI to talk with your database on that specific data. So let's see how you can do it, right? So let's start from the RAG pattern very quickly. I'm pretty sure you are already familiar with the RAG pattern. I see like RAG mentioned everywhere here. But basically you have your application that wants to talk with your data by sending a prompt to your application that implements the RAG pattern. And then what you do is actually turn the request into embedding, and then you go to your database, search for the related stuff using the embedding that you have generated. And actually, Azure SQL and SQL Server 2025 right now can generate embeddings for you. So it's very easy to go and get embeddings for your model. Then you bring back the vectors. You can store vectors in Azure SQL and SQL Server 2025. And then you basically complete, you do the semantic search, or even better, a hybrid search, mixing and matching semantic, vector search, and full text search. And then you send everything back to your application to complete the RAG pattern. The first step of the RAG pattern is the one described here, full text and semantic search. The second is taking the result that you got from your semantic query and then sending it to a more refined LLM like GPT-4o, so that you can really ask a question in a natural language, providing the answer that you got from your database and making sure that those answers are relevant for the question asked. So a RAG pattern is made of two basically sections. First, semantic search or hybrid search, and second, chat completion to make sure that the answers are actually relevant for the question. Now, this is fantastic. Unfortunately, it doesn't really work every single time. Why? Because it has some limitation. This is great when you have unstructured data or semi-structured data, like a text, a description, a sound, an image. But what happens if you try to use a RAG pattern against your structured data, like an invoice, like a contract, like anything that exists in a post-relational database like SQL Server 2025 or Azure SQL, where you can either store unstructured data in JSON or even XML if you want, or just plain text, and structured data in columns. Well, you have a problem because let's say now I want to ask to my AI agent, show me all the products in the category video games updated in the last 3 days or 3 months. Well, the RAG pattern falls apart because this is not a question that can be answered just reading some description and inferring basically the answer, right? You really need to generate a text, a query that is basically like this one. You need the AI agent to be able to generate and execute a query for you. And even more important, you need the AI agent to be able to understand when do what. So you need to move to a little bit more complex pattern called Agentic RAG, where you basically first have an orchestrator that understands what to do. Is this question something that I can answer precisely, generating and executing a SQL query? Or is this question something I need to answer using some semantic search, and thus I need to generate the vector and do the hybrid search and then put everything together? Now, no matter what path do you take, at the end of the first step, you will have the answer returned by looking into your database, either by running the SQL query or either by running a semantic search. Then you take the answers, no matter how you got the answer, and then you give it to a GPT-4o model, for example, or a refined AI model, so that the RAG pattern can be complete. You provide your answer, you provide the original query, you provide the context, and then the AI model can actually return a meaningful answer to you. That is great, and that's exactly what we are going to build in the next 10 minutes. So we are going to use an existing database. We will turn it into an AI agent just using pure T-SQL. Why I'm using pure T-SQL? Because I want to show you that is it possible. We baked into the SQL engine, both Azure SQL and SQL Server 2025, all the power that you need in order to build the Agentic RAG solution. Now, is that the only way to do that? Not, of course not. You have semantic kernel, you have LangChain, you have AI Foundry, you have many ways to do that. I want you to know that if you prefer to do everything in your database for security reason, compliance reason, now you can. We want to empower you to make the best decision, the best architectural decision for your solution, and this is how you do it. Now, I also have a nice cherry on top for this demo, because I will be creating a storage procedure, and then I need to publish it and make it available as a REST and GraphQL endpoint. How do I do that? A lot of work usually. Well, not, because we have an open source, free for everyone service and application that you can actually run on premises too, that is called Data API Builder, that in 2 lines of code will allow me to take my storage procedure and make it available as a REST endpoint with full Swagger capabilities, ability to filter my data, project, order, paginate, everything I need. So it's pretty cool. I only have 8 minutes now, so I better hurry. So let's move to the demo here. And first of all, is anyone able to see the text? Yes or no? Even in the back? Good. So this is my samples. I have some samples. These are real data. These are some of the many samples we created that shows how to use SQL Server with many other tools, specifically maybe for building AI. So for example, here I have an example that says how to use Azure SQL plus prompt flow, or how to do content moderation, or how to use LangChain and SQL Server, right? Now, what I want to build is a storage procedure. Now, imagine that this is your contract table or your customer table. I want to say, hey, can you please show me what samples are done using Azure SQL and semantic kernel? That's a query I would like to be able to ask to my database in natural language. And here you go, you have the answer. Well, let me also show what happens behind the scene. The procedure starts to, first of all, take the text that I typed as a query, so samples using Azure SQL with semantic kernel, and turn it into an embedding using an OpenAI model. So SQL is actually making a REST call to turn my text into an embedding using an OpenAI model I exposed, in this case using Azure OpenAI. But I could have used Ollama, and I could have run everything on premises if I want. I could use Ollama, I could use NVIDIA Triton, I could use VLLM if you really want to stay on premises. Of course, here I'm using everything in the cloud. Then after getting the embedding, I need my procedure need to figure out what to do. This is the orchestration part. Should this question be answered using a semantic approach or a precise approach? It determines that a semantic approach is better. So this is the query that is going to use to search in my database for semantically similar samples. And then it runs hybrid search, which means semantic search and full text search, calculate RRF, so reciprocal ranking fusion, to put together the result of full text and semantic search, and then generates the answer. Answer in a JSON format, because then it's sent to the AI model, a GPT-4o model in this case, to actually provide the grounding. Then I provide my query, my request, find me all the samples that are related to SQL and semantic kernel, and then will return to me an answer in a structured format. So let me execute this again. I'm using debug to show you this kind of log, and no cache because I don't want to use semantic caching. So every time I go and query OpenAI, just to show you exactly how everything works. So this is working pretty nicely. It takes a second because, of course, I'm connecting to OpenAI. And if it goes everything well, I have the answer. I can also ask other stuff, even more generic. I just want to build a solution to chat with my own data. Is there any sample that can help me in doing that? And again, using semantic search, hybrid search, vector search all together, I can find the most related sample to my question. And again, here, since I'm using the debug option for this sample storage procedure I created, you can see the decision tree and what happened behind the scene. But what happens if I ask something more precise, like show me the last 5 session recording of 2025? let's see what happened. Here now, for the previous question, I have semantic. Let's see what happened when I ask something more precise. I would expect this answer to come from a SQL query, right? So let's see. Well, first of all, we have the answer, and from my experience with this database, it looks correct. But most important, you see here that the strategy to answer my question was decided to be SQL, and specifically, this query has been created and executed for me. So let's say that this is a, here we go, a SQL document, and now I can format it. And you see that it did a select top 50 from, let me close this one and zoom in a bit. Some columns, the database, the table, and even a quite complex query because my database is a realistic database. So you have some data in a classic relational column, and some data is stored in a JSON data. Still, the AI model was able to actually generate the query correctly for me. So let's try another one. Let me see the latest code sample of 2025, and then we start and dive into the find sample functions or storage procedure. Again, the solution here was to use a SQL query, and the SQL query right now, it's of course even, oops, what happened? Here we go. Let me format this. Oh, F1, format, thank you, here we go. So this is the query that the AI model, again, decided to come up for my request. Very nice. Now, how all this works, it's incredibly simple. So I have my find samples here, and again, all this code is code you can download from GitHub already. So I basically implemented the workflow I described before. First of all, I need to orchestrate the request. So I use the storage procedure that I created, orchestrate request, to actually go and tell the AI model, hey, this is the table you have available. Please generate the SQL code for me, so that in T-SQL, so that you can answer this question. If you cannot answer this question just using T-SQL code, well, then I know that this question needs to be answered using a semantic approach, not a SQL approach, right? So the first step is to use this GPT-4o model to orchestrate the request. And then the output allows me to get to my find sample storage procedure. This is basically the orchestrator one. And then say, okay, if the orchestrator decided to use SQL and generate the query, then I do some sanitization, of course, and then I execute the query, and then that's it. Otherwise, if the orchestrator decided to use a semantic approach, then I run a semantic search using the new vector distance function, because I have a vector right now, because I transformed my embeddings into vectors, calculate the vector distance, do the full text search using frequent text table that provides DEM563 ranking, and then I finally calculate the RRF and then basically return the result. Results that are saved into a JSON path, because then in order to conclude my RAG pattern, what I have to do is generate the answer, and the answer this time I connect again to an AI model like GPT-4o, specify that you are a system assistant that helps user to find code samples. The query that was asked was the original query, and then this one, and then I provide all the samples I find in my database to make sure that the AI model has the grounding in order to be able to answer my query. That's it. Then I ask the AI model to answer using a structured output, so that then I can take the answer from my question, answer that is invoked. So I'm invoking the AI model using spvoke external REST endpoint that allows me to connect to a REST model and query it, to an AI model and query it. And then I just get the answer in a JSON format, and then I can show it as a table. Now that I have this storage procedure, I need to show it. And that's very easy, because all I have to do is go here, build, here we go, and then do dub init, initialize a configuration file, and do dub start. Add the storage procedure as something that is exposed as a REST endpoint, and then I can do dub start and Data API Builder will start, connect to my database, and allow me to query my storage procedure as a REST endpoint. Last 5 seconds, I just want to show you Swagger and the storage procedure being visible in Swagger as soon as this connects to the Azure SQL in Azure. Let's see if it's there. Localhost. Probably it's not started yet, but yeah, I think there is some connectivity issues. Oh, here we go. Now we have it. So now we have my database, my table, my find sample is now a post available endpoint. So I can query my database using just HTTP, which makes super easy for me to create my final solution, which is this nice website that you can reach at this address, ai.awesome.azuresql.dev, that allows you to talk with the data that is existing in my database using natural language. That's a rush, I know. Everything is available on this website, even the GitHub repository. Just go now back and start to talk with your data using Azure SQL and SQL Server 2025. Thank you.